good morning. Thank you for joining us so early in the morning, and we will be talking about knowledge graph, use of knowledge graph in large-scale documentation projects. And this is a common session between Martin and me. My name is Ulrike. I'm the founder of Parson, which is a technical communication service provider. We are based in Hamburg, northern Germany, and my specialty is in consulting for content strategy, intelligent information, and that's why I'm also a member of the IRDS consortium. Martin.
And my name is Martin Blumbach. I'm working for Ericsson, and there for the business area cloud software and services, and I'm the architect for cloud native technical documentation within that. And this is the rough outline of our presentation. So first we want to introduce the projects we are talking about, and the projects being the Anderson, Hauser and Parson project with knowledge graphs, and then the Ericsson project. And then we want to compare both with regard to several aspects. For example, why we use knowledge graphs, what is the system architecture we use, how do technical writers work, and so on. And at the end, we will also tell you what we learned, and it will turn out that we actually learned very similar things.
Similar things, yeah.
We could have selected other aspects, but we thought these were maybe most interesting. Change management could have been one, maybe. And we actually don't go into terribly deep technical detail on how this works. It's more the helicopter view, so if you have detailed questions, we are here after the presentation. As we are comparing the two projects, you will find often one of these two icons on the slides. So this is a slide where we found things to be similar with regard to one of the aspects, and this is where they are different. And how did we actually end here together on the stage, Ulrike? We were both at the last TCOM, right?
Yeah, we were on the last tcworld, and we both had sessions about knowledge graph, and we said, okay, that would be fun to actually compare that. Maybe also from a bit academic curiosity, but we actually found a lot of similarities.
And we thought the differences would be also interesting. So the similarities might mean that maybe this is something in general interesting, and the differences might be for specific use cases we have.
So if you're thinking about using knowledge graphs, or if you're already using knowledge graphs, then maybe you can benefit from our experience. So maybe enough introduction. Let's jump right into things. Ericsson is a world leader in mobile networks, and you see here a radio base station, which you probably see often outdoors or indoors even. But I'm not working for that part of Ericsson. I'm working for the core network part. The core network is what interconnects these base stations and connects them also to the internet, and which at the end makes it possible that you surf the internet, use services, make telephone calls, and so on. And the latest incarnation of that, 5G core networks, are cloud native, and that means they use technologies like Kubernetes, Helm, containers, microservices, and so on. And we will not go into terrible details what all that is, but about the complications it creates for technical documentation. And that is actually the problem we tried to solve with the project we started with in Ericsson actually some years ago. And the driving question behind all this was, how do we create technical documentation for software products which are flexibly assembled from microservices which are independently and frequently released? And you see a depiction of that on the right hand side. So we have a software product in orange, and that product has technical documentation, and the product consists of microservices. 3 in this picture, maybe 30 to 50 in reality. And now we'll say, well, Martin, that is hardly news, right? Products are built for ages from components, and now they're called microservices, so what? The devil is in the adverbs here. Flexibly, independently, frequently. These are all things which make you rather nervous as a manager for technical documentation. And that is why we use knowledge graphs actually.
So our customer Enders & Hauser had a different problem. First, let me introduce the company. It's a Swiss-based company with business units all over Europe and Germany. And they are a leading provider of lab equipment. So you find their measuring devices in the food processing industry, gas and oil industry. And one of the main characteristics of those devices is that they are highly configurable. So you see, this is one product line, but you already see in the pictures that they have different equipment attached, right? And then the software is also different, that's on the devices. So our driving question was, how do we generate matching technical documentation for a specific product configuration? And this highly automated. We didn't want the technical authors to configure all these product variants by hand in the technical documentation. And also Enders & Hauser wanted to use standards for intelligent information as much as possible in order to enable digital delivery later on. So that was our driving question. Now let's start with the comparisons. So why did we decide to use knowledge graphs? I mean, we could use any CCMS or whatever, or just metadata. But one problem is the range of the product variants. These are highly complicated. So you have different combinations, and then you have exclusions and inclusions. So what you actually need is you don't want to repeat all those relations in the CCMS, in your documentation metadata. So we actually wanted to use the product data directly and wanted to use the logic that is in the product configuration also for the technical documentation. And you can do that with knowledge graphs.
Another reason is the interfaces we have in these systems. So we usually have databases with fine-grained product information. We didn't want that information in our CCMSs. It's far too fine granular for that. Actually, what we wanted was a unified content store that can deliver structured content enriched with metadata. And then we also wanted automation and standardization. So we wanted automated workflows which can build information products and could assemble these on the fly. And we wanted harmonized and well-defined metadata model. And these were all things which knowledge graphs would give us, and they were common between the projects.
There are no differences in this aspect, or so the motives were clear and the goals were clear that we wanted to achieve. There are some differences in the details, I would say, and this is, but it's more in the details of the products themselves. So if you look at Enders & Hauser products, as I said, they have different business units and they all have their product lines. So they have like 600 to 800, and I hope that is correct. There are some Enders & Hauser colleagues here. They have 600 to 800 highly configurable products, and if you actually multiply all those configuration options, you get billions of possible product configurations, and that's the problem there.
And on the Ericsson side, we have far less products, but they are a lot bigger. So what we are currently addressing is around 10 of these big core network products. And what is actually a challenge is that they share a highly configurable common platform. That means that you also have to configure the documentation accordingly. And for these products, we have like hundreds of documents per product.
And we have just the regular stuff, technical information, installation instructions, operation guides. So this is like fairly normal with between 80 to 100, 200 pages. So there's nothing big there on our side. So the difference lies in the product configuration and architecture. That's another aspect we looked upon, and I think I'm starting right. Yes. So the architecture that we use for Andres und Hauser, because the knowledge graph itself is not the whole answer to the problem. We are using a commercial product which is called Empolis Content Connect, which you can look at this trade fair. They have a booth down there. And this is a combination of a knowledge graph and a data CCMS. So the knowledge graph holds the product model, so it gets the data from the product information management system, from SAP, from 2 software configuration systems so far. So we have all the product, we have the ordering options, the families, the software functionalities, and all the configuration stuff in the knowledge graph and in our what is called the product model. And then we also have an information model, which holds like a taxonomy for all the content that you need to write to describe those products. So we have interfaces there, and the data CCMS, of course, has an interface to the translation management system, but the documents are created by the knowledge graph. So the knowledge graph creates, right now it's PDF, but it will create IRDS, and it will create the asset administration shell for the digital twin. And we're also looking at CDP. So once you have that content storage and content repository and all that metadata, it's easier to deliver intelligent information from there. And now your picture, not so different.
Yeah, right. It's actually not that different, at least from a helicopter view. So we call the whole thing a content delivery pipeline, and it's a multi-source and multi-channel publishing architecture. On the left-hand side, we have 2 sources. One is our data CMS, and then we have, as these are software products, all kinds of software configuration files with relevance for customer documentation. So whatever is in these configuration files, which are maybe even purpose-created for us, that we want to reuse. Of course, we can't throw the configuration files at our customers, but some of the content of these files in a well-structured and integrated manner. And on the publishing side, in red, we have Ericsson proprietary HTML-based content delivery or portal. And we also have, but that is not a priority for us right now, we have online help and graphical user interface-based products. And very similar to Anders & Hauser, we have the intention to repurpose the knowledge we have in that knowledge graph and other types of product information, for example, learning or marketing, and to use the digital twin we actually built in this knowledge graph platform in other areas. For example, we can use it in an AI agent. So multi-source, multi-channel, you need something in the middle, and that is what we call knowledge graph platform. It's based on a commercial product. It holds the knowledge graph. It allows us to create and instantiate it based on a model and to have applications on top of it. And publishing to our content delivery portal is one of these applications. And we connect the whole thing to the software build pipeline on component microservice level, so build little baby knowledge graphs if you want, and then on product level to build a knowledge graph representing the product. And we also have an information part of that knowledge graph. So all in all, not that different.
Not that different, especially this being the spider and the web that connects different sources of truth to different outputs. That's very similar in both designs.
Yeah, so if we kind of try to summarize the similarities, so common is that we want to reuse product information for technical documentation, bridging silos, being that a CMS and all kinds of databases. And the knowledge graph kind of sits in the middle to integrate data from different systems. Then we have a shift left approach where we bring the technical documentation closer to the product development by using information from product development or even synchronizing it with it, which also creates new dependencies. we actually we synchronize the documentation with the software build or product process in an automatic way. And in the whole process, we build up consolidated product knowledge in the knowledge graph, kind of as a byproduct, if you want. And that can be used for other purposes. AI is one of these.
It's like a hidden treasure that just gets larger. The more sources you get and the more data you get via these sources, you build up a product treasure, I would call it.
Yeah, I would use the same term, actually.
Yeah.
Then we have, maybe not so relevant here, but we have realized that we both use Ditter actually with Oxygen as an editor, and we use commercial software for the knowledge graph, but that is actually different commercial software, and that is interesting.
Exactly, and that brings us to the differences. So we use a TechDoc specific solution. So our knowledge graph is integrated with CCMS as one solution, and the interfaces between those two are managed by the vendor. So whenever the data needs to be transferred, they need to make sure that it works. But that also means that we still are dependent on what you talked about, this shift left approach. When there is no product data, then we cannot start the documentation. So shift left also means no product configuration, no documentation. Yeah. Sorry, I was sidetracking.
Yeah, we took a different approach. After we defined our requirements, we did quite some market research, and we ended up not with a documentation specific software product for the knowledge graph handling, but with a general enterprise digitalization software, which is Accenture Corporate Memory, as a framework to build, first of all, to instantiate knowledge graphs, and second, to build applications on top of it. And we ourselves build low-code workflows in that framework. So we develop the application. And we use the Graphite GraphDB as graph database. From a triggering perspective, our solution is triggered from the software delivery pipeline, and it can or should actually be triggered from the component management system as well. But in your solution, that's different?
Yeah, the knowledge graph is first. That means whenever we get a new product configuration in the PIM, in a product information management system, for instance, and we import that, and then we can start the documentation. So it's a complete different approach to working. You can no longer simply start writing a document. That doesn't work any longer. You need a product configuration, and then you can set up your documentation project. So the knowledge graph triggers the CCMS. The good side is that the knowledge graph collects all the information units, all the topics that are required for this product configuration. So this is completely automatic, but it still creates a dependency. Yeah, we have more data sources than you, if you want to count. We have, right now we have 4 data sources connected to the knowledge graph. And you have like 1, the software configuration.
We have 1, but it holds very different configuration files, which we have to interpret, and we have also to connect information from these. And from a modeling perspective, we use W3C standards, that is RDF, RDFS, and all which the platform we use supports natively.
Yeah, and we could export RDF, but as I said, it's a proprietary software, and they use a proprietary semantic model and language and query language and all that, which is both an advantage and a disadvantage. The advantage is you have a UI and you have functions, and it's just a commercial product. The knowledge graph is more in the background, but on the other hand, you are not able to influence the system as Ericsson is able to do. And I think it kind of creates a bit of a vendor lock-in, because when we want to switch the vendor, we need to get the semantic data out at in some format. Yeah, but that would be possible. Is that I'm starting? Ah, yeah, okay. Yeah, that actually continues. And the video is just to get a visual impression of how our technical communicators work. So this is, I said you start with the product configuration and you see you have a web client, you select a product. First you select, okay, I want to talk about assembly. And then I select this taxonomy node in my model, and then I select a product. And this comes with all this. When I select a product here, it can be a family, but it can also be lower than that. And then you get all the configuration options, all the ordering options, all the possible communication protocols that the device has. That's all integrated there. And then I can start my documentation project. I can I have to fill in some stuff like the deadline, who's responsible for writing, who's reviewing. And this is then, and then the knowledge graph starts to collect information units. So you rarely start from scratch, right? You have a previous product variant, or it's a variant like a side project. Side product variant. So the knowledge graph collects all the topics, the data topics that are already present for this product feature, for instance. If you have already written about assembling a device with a clamp, then there's a topic about it, even if it's on another product. But if it's the same product property and the same fastening method, then you can reuse the topic, and the knowledge graph selects that. If it doesn't find a fitting topic, then it creates new ones. So that is all automatic, and then this is transferred to the CCMS, and the topics have not only the right topic template, like task, topic, reference, troubleshooting or whatever, but they also have all the metadata. So all the metadata is transferred from the knowledge graph to the CCMS. The technical writers no longer assign any metadata. That all comes from the knowledge graph. And that is a big plus of the solution, I think, because it's not only the metadata you need for variant management, but also the stuff that you need for content delivery, which is a lot more, like product family and product series and variant and stuff like that.
Yeah, and this is kind of depicting the work process in Ericsson, and is different from the Anderson-Hauser solution. And in that world, the way of working for a technical writer hasn't changed much. So the tech writer basically uses the CMS and the existing content creation process where you agree with the development organization which topics you create hasn't changed much. But this knowledge graph platform delivers auto-generated topics to you which you can integrate. So it looks a bit like a colleague creating these topics on the fly based on product knowledge. So you don't have to care about these topics, and often aggregation topics with information across the product. Sometimes, not often, but sometimes technical writers have to make sure that metadata is added to manually created topics. So that's the left-hand side, mostly unchanged. And on the right-hand side is where the differences are. So we, in this knowledge graph platform, we, knowledge engineer, information architect, create workflows. We develop the application, which instantiates the knowledge graph and creates documentation and publishes it. So there's a new specialized role. And then the knowledge graph platform, like Treasure, as you said, offers the product knowledge graph to subject matter experts. So they can review if that product they are seeing there is actually the product they think how the product should look like. And if they agree to what they see, that view is automatically translated into documentation. They don't have to review that everywhere again. And here's an example of such a view for a subject matter expert. It is starts with a Sankey diagram, which puts the most basic things you could say about a product for mostly a system architect into a drawing. It's a function exposed to the end user in red on the left-hand side. Then how this is implemented in an end-to-end fashion by a microservice, and then the interfaces the product exposes in the network, for example, SNMP to report alarms to a network management system. And below that, and you see at the top of that, are then tables with the different objects, so to say, in the knowledge graph, so the microservice and their property, the interfaces, the certificates, and so on. So it's a overview first, zoom and filter details on demand design if you want like a window into a knowledge graph.
Yeah, and that's something that you always have to do when you work with knowledge graphs. You need to find a simplified view on the data, right? That you see like one piece or one chain of information at a point in time, and you, as your SMEs, that they correct those relations between the technical items. Because once you dive into the knowledge graph, it just explodes. There's so much data, so you need to find a way to expose simplified views to the users. So this is actually the third point here, that we both of us have an abstraction layer, so that working with the semantic structures become easier. When you develop the model itself, like what type of objects you want to have, what concepts, what relations, that is normally not that complex. But when you start filling it with data, then you have hundreds, thousands of instances, and that's why you need this abstraction layer. The people working with the knowledge graphs, as Martin said, we have different roles now, and that also holds true for Endres and Hauser. We have now a differentiation between information architects and technical writers, and even between information architects and task managers who assemble those documentation projects. And the information architects are responsible for defining the we call that variant configurations or variant selections, so which product metadata actually create a documentation variant. These relations need to be created and maintained so that you actually get a fitting documentation for a product variant. So you have different roles coming up in the typical technical writer who gets the input from SME, from an engineer. That's no longer the work we are restricted to. It's much larger and more thrilling, more interesting, I think. What else? We both write data, we said that, and our SMEs work in web-based clients, yours with those flows. And we have a typical review client where they actually look at topics and then sign off the topics. That's for a specific information product. So our workflows are integrated product features. So whenever we want a new one, or we want to have a different view on the semantic data, we talk to Empolis and say, okay, we want to have this feature because this is a co-development project. So we've been working on that for 3 years. We are going live in January. We are all a bit excited now because then now we roll it out. But this is actually a commercial product, so the workflows are integrated.
And we create the application, so to say, in low-code workflows, which have become quite huge.
Yeah.
And we have cases where technical writers or communicators have to manually assign metadata to topics. It's not many, but it happens.
Yeah, and we see the metadata, the technical writers, when they are in Oxygen, and in the CCMS, they see the metadata, and they can also merge topics that they have very similar content, but otherwise they don't touch the metadata. They can't even reach them. They can only see them. Data is fairly standard for both of us, a bit constrained and a bit specialized, but not much.
Yeah, we have also constrained data actually, but we have defined topic classes, so a kind of extension of data topic types to specify how to use a topic type for a well-defined purpose. So for example, these systems can raise alarms saying that something is not correct, and then we have a specialization of the troubleshooting topic which tells you how to actually fix that issue with a remedy and how to specifically use a task troubleshooting topic.
Okay, automation.
Automation
That's yours.
is actually quite similar. So we both assemble information products from a single source of truth, and we consider product variants, or in our case, the platform based on metadata. And we build stuff, handle stuff below topic level. Fragments, we actually handle variables to some extent, data variables in our case. So these are existing things, and then we auto-generate, or at least plan to auto-generate data topics. We do that in our solution already. So we generate topics from the knowledge graph. And what we also don't do yet, but plan to do, is to reuse the knowledge in the knowledge graph in, for example, an AI agent, or we can augment web pages in the enterprise and so on. So that's very
common, yes. So we want to have we're going to have a POC next year where we inject the data or the information from the knowledge graph to an IoT platform to give more content to error messages, and that's one of the plans that we have. Concerning the content module, so it's needless to say, because we get the data from the product sources, we have variables for technical data, for menus in the software, so this is all automatically drawn from the source data and then put into the documentation as variables. Okay, that was actually that's a difference to we did that task in Stockholm together this year, and we added this slide for this conference because Anderson is going live in January, and we are just in the very hot last phase of implementation and testing. And we both noticed that when you go from an implementation to a productive use, then you still have some work to do, and you need to consider different aspects. It's no longer a nice and fancy solution that you play around with, but this is a solution that people rely on. So you have to make sure that it has a good performance, it's stable, it has reproducible results, and you need to educate the users. So what we've been focusing on is a test strategy. For Anderson Hauser, we can say that we have 3 types of testing. We have testing within the sprints. We have test suites that are maintained in a test management tool. And then we have, we call that pre-tests in parallel to the implementation. And then we now are going to start a user acceptance test, a big user acceptance test. So you need kind of test strategy and to get the solution up and running. And also you need to take care of user education. So you need documentation, training, and also architecture documentation, because the solution is going to live longer, hopefully, than the time that you developed it. And you need a process for filing feature requests for the futures and bug reports. So this is nice because Anderson Hauser invested a lot of money also for user documentation. As I said, it's a co-development. It's a Anderson Hauser specific implementation, but which becomes a product. So they invested in their user documentation quite heavily, which is nice. This is generated also in Oxygen from the system, and this is Oxygen Web Help, and you have different entries into the documentation based on your role as a technical writer, information architect, and so on. But of course, there are differences. We focus a lot on user acceptance test, which is probably caused by it being a commercial solution, and you have a different approach.
Yeah, we have started to work with user acceptance tests, but what we have focused on before was automatic and manual knowledge graph sanity checks. So while we build the knowledge graph, we check if there is any issues with that. And that, I think, was essential to get forward. We have also started or done quite some things with release notes now per release of that platform or application we are providing, and we have a forum-like approach for users, and we have started to create architecture documentation for the whole thing. So how does it actually work internally?
Yeah, and I was a bit jealous when I looked at Ericsson's architecture documentation. It's quite profound, and we have started it, but we are not there yet. We have started to also, when you look at the operation phase, you need to make sure that people have a way of finding the sources of errors. So you need logging, reporting, troubleshooting advice and stuff like that. You don't always want to go back to the vendor and ask, okay, my system doesn't do what it should do. And this is something that we started in this co-development project, that we want to have a way of locating errors, looking at the logs and finding errors ourselves.
And in that area, we have key performance indicators to see how the system is actually doing. We are developing functions for cross-charging the use of that platform. And then we have a dashboard for basically to see these documentation and knowledge graph builds, and we also have workflow execution log. The letter is given to us by that platform we use. And we have an example for this dashboard. So this is basically a table that where each row is a build attempt of a product level knowledge graph with the associated documentation. And you see if that is for a released product or a product in its staging pipeline. You see when that happened, if it's successfully completed, and you see the build time, which is like 20 minutes. And I would say 30% of that is actually waiting for surrounding systems to write stuff to the CMS and publishing triggering the publishing system. And you can drill down to see deeper into how this works, and that is, I think, essential to understand what's going on below the hood of this thing.
Yeah, we are not there yet. Okay, so what did we learn? We learned quite a lot. This has been very good experiences working with Knowledge Graph, because they do actually what we expected them to do. So we reached our goals. But if you want to bridge silos in a company, especially in a larger enterprise, you need to be a bit spidey as well, because you have to connect people. You have to go to managers, to stakeholders, to get the data that you need. For instance, if not every product is in a PIM, in the product information management system, you need somebody to go to and say, okay, we need your product in the PIM, otherwise we can't create documentation for you. It worked before, but now it doesn't work any longer. Please do something. So you need management support and stakeholders. Second is that knowledge engineering is not a common skill. It's not taught at universities for technical writers. Semantic models is something that people need to learn, semantic modeling, and also the Anderson Hauser information architects need to understand how the basic relations in the semantic network work, because they need to create relations that decide which documentation variants are generated. And I talked a lot about this. A productive solution is very different from a pilot or an implementation solution. You need to make sure it works. You need to test it thoroughly, and before you actually go live.
Yeah, and I can sign all that. And then is a second set of things I think we both learned, and that is data is the key. So there is no such thing as clean data. The data from the silos you have will be highly diverse. It will probably not be well connectable, like fair data, findable, addressable, interoperable, reusable. And the data you need might not even exist. So you might need to talk to a development organization that you have additional needs. Then I think it would be a very bad idea to do something like this with a waterfall development approach. There's far too many things you learn on the way. Agile works for sure best for it, but you need a good grip on information architecture and system architecture if you want to do that. And you need to be willing to throw away things also. That is a consequence of an agile approach. Remote working is fine, but you need some face-to-face meetings. You need to know the people you're working with, as this is highly collaborative. And you might not want to apply this to all products you have in your enterprise, because not all might be able to invest in something like this. So you need to focus on where most of the business value is. You probably want to prioritize new products or products where you see the best business case, and you might need to provide hybrid ways of handling this. And that is always not so nice if you want a very clean information and system architecture in reality.
Yeah, and it doesn't work in our way because you can either do it in a knowledge graph or not for Enders and Hauser, but maybe the old system is still active and they may want to leave some products there. Our favorite quote?
Yeah, I think that's the biggest learning of it all.
Yeah. It's not a sprint, it's a marathon. It takes time. You need to be patient. You need to be resilient. But then it's worth it.
It's definitely worth it, and it's maybe a bit of the curse of the whole thing, because with an AI agent, I think you can show things very quickly, but it always works 80%, and getting the 20% is a very long thing. But here, getting the first 20% to work is really a lot of work. So this is also a communication with management issue and product management if you want to push something like this.
It's a complex approach, but the knowledge graph gives you 100% more easily than a chatbot or an agent, because it's reliable, it's predictable AI. So thanks for listening. If there are any questions, I think we have like 5 minutes left. Okay, there's a microphone, I think, so everybody can hear the question, and the young man decides.
Okay, thank you for the theory. I think it's a very insightful topic, and I wonder whether it is possible to demonstrate how you combine all this, what you have introduced right now, into real world use cases. So you mentioned about the knowledge graph, how you integrate into your current workflow. Currently, you mentioned that you're using data oxygen, right? So I wonder how you integrate this into your workflow. I think it would be helping better to understand what you have introduced. Thank you.
Yeah, we can show you. I can show you the Enders and Hauser or the Empolis Content Connect product at our booth if you're interested, because that would have been too much for this session. I don't know whether you can demonstrate your way of working, but I can definitely show you the product.
Yeah, I would at least refer to this architecture picture we had in the beginning, which gives you an idea how we interconnect the different systems and how they would work together. But that is only the high-level architecture. There is at these 2 levels below that. But if you want, we can talk about that after the presentation.
Thank you for a great presentation, and I've seen it a couple of times, so I feel like I'm starting to understand, which is good. And I think that from a management perspective, because everyone's talking agentic, and we've almost skipped AI now, so now we're talking about we need agents everywhere that are going to do these jobs. And I'm sitting looking at what you presented, Ulrike, and the steps and the things that they clicked, and you sort of thought, well, an agent could do that. And that's what managers think. So my question is really around the business case for this, because I get it, but how do we get management to get it? So you talk about investment and savings. Do you have something that supports that?
To show that you had savings, you need figures before and after, right? And that's one of the main problems as a consultant, that people have no before figures. They don't measure the time that they need for a specific information product. Second point is that they've never been able to produce order-specific documentation. They had documentation for families, so you are comparing apples, not even apples and oranges, you compare Me Too oranges, because it's a different menu. So you can do more, you can do it reliably, and of course you could ask an agent to say, okay, create me a documentation product for this variant and for this part of the information tree, so to say. But that an agent really goes in all to those sources and gets the data without you having a model and having the dependencies, that's not possible. Sorry, I doubt that, because you need those dependencies. You need to say, okay, if the customer clicks, they want a product with a clamp for assembly, then that triggers a documentation variant. So an agent cannot know this. You need to hardwire this relation in a knowledge graph, and that's the reliability it creates. And agents can help you on the way, I think, can make life easier, but they cannot replace the actual knowledge graph, in my opinion.
Yeah, my answer would be I would actually try to build a prototype where you bring knowledge from a knowledge graph to an AI agent for a given use case. Being that question answering, or being that documentation generation or documentation review, or whatever use case is important to you, and then to showcase the difference it makes if you bring a knowledge graph, maybe with an MCP server, to that agent, and to compare that and evaluate basically the value add. That is a proposal I would have for this.
Yeah, and I think it's actually supplemental. So you would actually use the knowledge graph, the treasure that we talked about, and then you put an agent on top that, for instance, creates you data sheets. So this is they supplement each other, the approaches. That's what I think. Okay, we are out of time. If there are any more questions, feel free to come. But we just got a signal from the back.